the circles module. In lesson 11, we are going to look at secant lines that meet inside the circle. So I am looking at two secant lines that are going to meet inside a circle. Now, the opening exercise is a warm-up problem, and you all should be able to do it on your own. So please pause the video if you haven't done it already, and if you have, then look at the responses with me. Okay, find the value of A and B, and I know that DB is a tangent and DC is a secant. Okay, so let's look at A and B. Okay, so I can see that this angle is given to be 87 degree, and this angle is the supplementary angle to 87 degree. So this is going to be a 93 degree angle. If this is 93 and this is 74, then sum of angles of a triangle is 180 degree. So that tells me that this angle right here is going to be 13 degrees, because 93 plus 74 plus 13 is going to give me 180 degrees. Okay, so now this angle, angle DBE, is the angle that is formed by the tangent BD and the secant BE. So if this is 13 degrees, that tells me that this arc BE, from what we learned in lesson 10, this arc is going to be twice of this 13 degrees. So this arc is going to be 26 degrees. So if that is 26 degrees, then A is the inscribed angle for that arc BE. So A is going to be 1/2 of 26 degrees, and it is going to be 13 degrees. So A is 13 degrees. So then B, again, I can look at the triangle BCE, and the sum of angles of that triangle is going to be 180 degree. So that tells me that B will be 180 minus 87 plus 13, or 180 minus 100. So angle B is going to be 80 degrees. Okay. Part B, they're asking me, is BC a diameter of the circle? Yes or no? So we can't see the center of the circle, so we can't see if BC is going through the center. Another way we can check if BC is a diameter. If BC is a diameter, then this angle BEC, should be 90 degrees according to Thales' theorem. Well, it's not 90 degrees. It's given to be 87 degrees. So that tells me that BC is not a diameter. I'm going to write it down. No, because if CB is a diameter, then according to Thales' theorem, angle BEC should be 90 degrees. So as angle BEC is equal to 87 degrees, so CB is not a diameter. You can pause the video here and copy this explanation down. Moving on, we are going to look at another theorem today. It's called the secant angle theorem, interior case. And as we go through the theorem, you will understand why am I calling it the interior case. So the theorem reads that the measure of an angle whose vertex lies in the interior of the circle is equal to 1/2 the sum of the angle measures of the arcs intercepted by it and its vertical angle. So in a sense, what it's saying is, let's use this diagram. This is the diagram I'm looking at. So I'm saying that if there are two secants, so I'm given secants RS and PQ that intersect at point A. Now very carefully look at it, that some of you might think that these RS and PQ are chords. They are chords, but chords are just special secants. That's the only difference. They're a special kind of secant. And these two, both RS and PQ, are not diameters of the circle, because none of them is passing through the center. Having said that, then we know this angle A is not a central angle. Please be very careful. Angle A is not a central angle. So please don't make that mistake. So what the secant angle theorem is saying, and that is what we are going to prove here, that the angle whose vertex lies in the interior of the circle. So this angle A, whose vertex lies in the interior of the circle, so A should equal half of the sum of the angle measures of the arcs intercepted by it. So the arcs that are intercepted by angle A are this arc PR and QS. So these are the two arcs. So what secant angle theorem says is that A should equal B plus C divided by 2. And that is our angle secant theorem. The proof for this is really simple. This is just an extension of the inscribed angle theorem. And to prove that, what I'm going to do is I'm going to join points R and Q. So my construction is join points R and Q. Now I've created a triangle ARQ. I am going to call this angle 1 and this is my angle 2. So you see, angle 1 is going to be 1/2 of C. Can you tell me why that is? And similarly, angle 2 is going to be 1/2 of B. And the reason for both these statements is these are coming from the inscribed angle theorem. That because 1 and 2 are both inscribed angles, and 1 is the inscribed angle for the arc, the arc is PR, so it's going to be half of that arc. Now look at angle A. Angle A is equal to angle 1 plus angle 2. Can you think of a reason why that is true? Well, that is true because the exterior angle of a triangle equals the sum of opposite interior angles. So A is 1 plus 2. But 1 is half of C and 2 is half of B. I have just done some substitution here. And look what I have proved. I have proved that A is B plus C divided by 2. That is what my secant angle theorem is. So take a minute, look at this theorem, understand what the secant angle theorem, and this is the interior case of it. So please be very careful. This is the interior case because my two secants are intersecting in the interior of this circle O. So at this point, I want you to pause the video and go to the figure next to it, figure 2. And here, can you prove for me I want you to prove on your own that again A is equal to B plus C over 2. So again you are proving the secant angle theorem for me again here with this figure now. So go ahead, pause the video, copy this one down, understand what the secant angle theorem is, and write a proof for this other figure. Okay, moving on then. Let's see if we can apply this secant angle theorem to find the missing angle measures. So here they're asking me to find x, and I'm given that this arc CD is 40 and arc BE is 120. So you can see that the two secants are intersecting in the interior of my circle, creating this angle x. So angle x is going to be 120 plus 40 divided by 2, so which is 160 over 2, which is 80 degrees. And I have used the secant angle theorem interior case to prove this. I am sure you can do B on your own and later on come back and do B, part B on your own. Let's move to exercise 1. Now in exercise 1, I am given that PO is the radius of circle P. So then let me call this point N. So ON is going to be a diameter because this is a straight line and it's going through the center. So this is a diameter. And I'm also given that the measure of MO, the arc MO, is given to be, it should be 142 degrees because that is what it's given. MO is 142 degrees. It's not 14 degrees, people. Please make that correction. Your job is to find angle MOP. So they're asking you to find this angle. Now you can use, I'm going to call this X. And I can use the inscribed angle theorem here. So I know that arc NMO is going to be 180 degrees, and this is because NO is a diameter, and the diameter is going to cut my circle into two equal arcs, and each of them is 180 degrees. So MO is given to be 142. So NM is going to be 180 minus 142. That is going to give me 38 degrees. That is going to give me 38 degrees. So if this arc is 38 degrees, using the inscribed angle theorem, I know that X is 1/2 of 38, which is 19 degrees. Also, I could have used the secant angle theorem. So let's see how we can use the secant angle theorem here. Secant angle theorem, these two secants, MO and NO, they are intersecting on the circle. So this X is going to be 38, and we all know how we came up with 38 for the arc MN, plus, what is the arc on the other side? It's 0 degrees over 2. So that also gives me 19 degrees. So you can see that the secant angle theorem, the interior case, and we are going to look at the exterior case tomorrow, is just an extension of the inscribed angle theorem. Okay, moving on then. Let's go to exercise 2. So exercise 2, I am given that the arc CE is 55 degrees, but I'm also looking at all these parallel lines. So I'm looking at this line is parallel to this line, Let me highlight them by the same color. So these two lines are parallel, and so are these two lines. And I'm given that this arc is 55 degrees. I'm being asked to find this angle DEF and the measure of arc EG and this arc right here. Okay, so look at your cheat sheet and see what can you find about parallel lines. So we learned before that parallel lines in a circle, they form equal arcs. So if this arc is 55, then this arc DF will also be 55 degrees because these are the arcs in the middle of the parallel lines and they are equal. So if that is 55 degrees, can you see how much DEF will be? It will be 1/2 of that 55 degrees or 27.5 degrees. This is using my inscribed angle theorem. Okay, good. So I know this is 55 degrees. But now let's look at my two orange parallel lines. You can see that DF and EG are the two arcs that are being created by the parallel lines. So they should also be equal using the same theorem. So this EG should also be 55 degrees. Okay, I want to do, I think these problems 3 and 4, you can also do it on your own. And so is 5 and 6. I want to work on problem 7 with you. So let's look at problem 7 together. I am now in this, I'm given a circle where BC is a diameter. So that tells me that this arc BEC and BDC are both. So arc BEC and arc BDC are both 180 degrees. And this is because BC is a diameter. Also, I know that DC, the ratio of DC to BE is 2:1. So if I say, hey, this measure of this is some M, then CD is going to be 2 times M. And they're asking me to prove that the angle Y is 180 degrees minus 3/2x. Okay, so let's look at this together. So I can see x will be equal to 1/2 of 2m. So it is m. And this is just my inscribed angle theorem. And then I can also see, okay, let me call this angle Z. This is the third angle of the triangle BFD. So I can also see that Z is 1/2 of M, which is m/2, and this is also inscribed angle theorem. Now, in triangle BFD, I can see that x plus y plus z should equal 180 degrees because these are sum of angles of a triangle. So let me substitute the value of x and z in terms of m. So this will give me, this is I can say that z, because x is equal to m, so z in terms of x is x/2. So I can say this is x plus y, and z is just x/2 equals 180 degrees. This is just substitution. So then 3/2x plus y is 180. This is just simplification. So y is 180 minus 3/2x, and this is using the subtraction property of equality. So the rest of the problems on this packet, I think you should be able to do it on your own. I am just going to give you the answers to all these problems and see. So try and do all the other problems on this handout on your own, and then come back and check your answers with my answers. So at this time, I want you to pause your videos and go ahead and finish the packet on your own. Okay, so here are my answers. This is page 2. And here is B part of example 1. I got x to be 31.5 degrees. We did exercise 1 and 2 together. And here are exercises 3 to 7. So look at problems 3, 4, and 5. Go ahead and pause your video because I'm going to move the paper. And here is number 6. Moving forward, we did exercise 7 together, and these are the homework problems. Here are my answers to the first 4 problems. Let's see if I can move it enough. Here it is. So these are my answers to 1, 2, 3, and 4. Pause the video if you need more time to look at any of these solutions. If you are done, I am going to move to the next page. And here is the solution to number 5 and number 6, a step-by-step solution. Please pause the video if you need to look at these solutions carefully. And here is number 7, where I got my x to be 108 degrees. Okay, everyone. So in this lesson, we have worked on the secant angle theorem interior case, which tells me that if 2 secants are intersecting inside a circle, then the angle that it forms is going to be 1/2 of the angles of the 2 arcs that it creates, 1/2 of the sum of those. So please take a minute, go back to the secant angle theorem and understand it completely. If you have questions, you know where to log them. And once you are done, please go and see if other people have logged in any questions that you can help answer for them. That's all for lesson 11. I will see you with lesson 12. Bye.